Hello students, so in previous lecture we discussed about some basic concepts and we also discussed about redox reactions or definitions of reduction and oxidations in detail again. Now we will discuss one more new definition of redox reactions, that means reduction and oxidation. That means redox reaction in term of electron transfer reaction. So whenever electrons transfer from one atom or reactant to other atom or reactant, it is also considered as redox reaction. In some cases, we may find difficulty to identify the redox reaction as we discussed in previous lecture. One of the reaction was between sodium and hydrogen gas, which produces NaH or sodium hydride. Okay, to balance the chemical reaction, we can put 2 moles of Na, it will produce 2 moles of NaH. But this is not the point. Our main point is, as we can see, we added hydrogen into the sodium. So according to the definition, if we add hydrogen, it is considered as reduction. But if we compare the electronegativity of sodium and hydrogen, then sodium is less electronegative than hydrogen. That means we are adding electronegative element to sodium, and as per the definition of oxidation, if you add electronegative element, then it is considered as oxidation. So we are adding hydrogen, that means reduction, but we are also adding electronegative element than the sodium. So that means it is also oxidation. So which type of reaction is this? So actually this reaction is oxidation of sodium and reduction of hydrogen, because in case of oxidation we add electronegative element. So here confusion arises. So what we can do? So we can check the electron transfer of this reaction, and based on the electron transfer we can identify oxidation or reduction. So that's why let's learn about the redox reaction in terms of electron transfer. So here some reactions are mentioned: sodium with chlorine, sodium with oxygen, and sodium with sulfur. So all of them gives NaCl, Na2O and Na2S, that means ionic compounds. In ionic compounds, one of the species will be positive ion, second one will be negative ion, and both of them, because of opposite charges, attracts each other, and it is known as ionic bond. Now in all of these three reactions, sodium is being oxidized because we are adding electronegative element into the sodium. According to definition of oxidation, if you add electronegative element, then it is considered as oxidation. So in this reaction, we are adding chlorine, oxygen and sulfur into the sodium, and you will get respective products as mentioned. So that's why it is oxidation of sodium. Then what about the reduction? If something is being oxidized, then there must be something else which is reduced. So same thing we can think in reverse. If sodium is being oxidized, then we are adding sodium into chlorine, oxygen or sulfur as well, because both of them are in combined form after the reaction. That means we are adding chlorine into the sodium and sodium into the chlorine. So we are adding electropositive elements into chlorine, oxygen and sulfur, so they are being reduced. So in all of these three cases, sodium is being oxidized and chlorine, oxygen and sulfur, they are being reduced. So that's why this is a redox reaction. So as we can see, in all of these three reactions, one of the reactant is being oxidized, one of the reactant is being reduced. That's why it is considered as redox reaction. And as we already discussed, sodium chloride and or some other examples as mentioned, sodium oxide and sodium sulfides, all of them are ionic compound. That means one of the element is positive, one of the element is in negative oxidation state. So we can represent them as Na plus and Cl minus, or Na plus and O2 2 minus, or Na plus and S2 2 minus. All of them carries some charges. We already discussed about how can we identify these charges in previous lecture. But still, let's give right away the oxidation states of each elements mentioned here quickly. So we have four elements: oxygen, sodium, sulfur and chlorine in these three reactions. So all of their atomic numbers are mentioned along with the symbols. So next thing is, you have to find the nearest noble gases to each. So we know that if oxygen is at number 8, then nearest will be neon, which contains number 10. For sodium, again nearest will be number 10 neon. For sulfur, it is argon because it is 16 number, so it will be comparatively closer to argon, which is number 18. And similarly for chlorine, again nearest will be 18. So all you have to do is just balance the electrons. That means in oxygen we have 8 electrons and we need to do it 10. So that means we have to add 2 electrons. That's why it carries -2 charges. For sodium, it has 11 electrons and it needs only 10. So it will release one of the electrons. So it will get +1 charge. For sulfur, it is 16 and it needs 2 electrons to get argon-like electronic configuration. So common oxidation state -2. Similarly, 17th number chlorine, we need 18 electrons to get noble gas-like electronic configuration. That's why chlorine carries -1 oxidation state. So that's why these charges are mentioned Na plus Cl minus O2 minus and S2 minus. Now as we see the step-by-step reaction, then as we can see for each and every reaction we have electron loss and electron gains. In case of first reaction we have sodium atoms and chlorine gas. So 2 sodium atom loses electron and it produces positive ion, and these electrons released by sodium will be gained by chlorines and it will convert into Cl minus ion. So sodium loses electron and chlorine gains electron. So as mentioned, according to our previous definitions, if we add electronegative element, then it is oxidation. So that's why we are adding chlorine into the sodium, and that's why sodium follows oxidation. Similarly, we are adding sodium into the chlorine, so we are adding electropositive element into the chlorine. So for chlorine it is reduction. So similar situation can be observed with loss or gain of electron. If electrons are lost, then it is oxidation, and if electrons are gained, then it is reduction. So whenever elements loses electron, they gets oxidized, or whenever oxidation state increases. Oxidation state, that means the charges mentioned on the top of the species. As we can see for sodium, as mentioned after the reaction we have Na plus mentioned because it do not have equal amounts of electrons and protons. In sodium we have 11 protons and only 10 electrons. That's why it is positive. In chlorine we have 17 protons and 18 electrons. That's why it is -1. So these charges mentioned on the top of the symbols are represent as oxidation state. And if nothing is mentioned, then it represents it has zero oxidation state. That means before reaction sodium has zero oxidation state, before reaction chlorine also have zero oxidation state. So if element loses electron, then obviously charges will increase or value of oxidation state will increase. So if value increases, then it is oxidation. If element gains electron, then charges will decrease or value of oxidation state will decrease. So if value decreases, then it is reduction. So that means we have some more definition again for oxidation and reduction, which is oxidation, that means loss of electron or increase in oxidation number, and reduction, that means gain of electron or decrease in oxidation number. Similarly, second reaction is also mentioned. We have sodium with zero oxidation state, oxygen gas with zero oxidation state. Sodium loses 2 electrons and one of the oxygen gets 2 electrons. So each sodium atom will gain +1 charge. So we need 2 sodium to get +2 charge because we have -2 oxidation carrying oxygen, because oxygen gains total 2 electrons. So Na plus and O2 minus combined to form Na2O. And similarly we have last reaction, same type of reaction just like the previous, that means sodium and oxygen. We have sodium with sulfur. Sulfur gains electrons, sodium releases electrons. 2 sodium releases 2 electrons, 1 sulfur gets 2 electrons, and you will get Na2S2 minus. Now for the convenience, we can separate the redox reaction in two different steps: reduction half reaction and oxidation half reaction. And we can simply represent each reaction with either loss of electron or with gain of electron, so that we can properly see which of the element is being oxidized and which of the element is being reduced. So as we can see in this reaction, initial reaction was 2Na plus Cl2 produces NaCl directly. But in this reaction we have two different steps. First step, it shows oxidation of sodium. That means sodium loses electron and it increases its oxidation state. Before reaction we have zero oxidation state from the sodium. That's why it is not mentioned on the top of the sodium metal, but we can mention it like this. So sodium before reaction has zero oxidation state. After reaction it gains +1 oxidation state, because two sodium atoms releases total 2 electrons. Now these two released electrons will be used by Cl2 gas. Before reaction Cl2 gas also has zero oxidation state, but it will get 2 electrons because we have two chlorines. Both of them will get 1, and it will change into -1 oxidation state. So change in oxidation state are, for sodium it is 0 to +1, for chlorine it is 0 to -1. So as we can see, in case of sodium it is increasing, in case of chlorine it is decreasing. So that's why sodium follows oxidation, chlorine follows reduction, and both of these reactions are known as half reactions. That means first reaction is oxidation, that's why it is considered as oxidation half reaction. And similarly, second one is called reduction half reaction. So both of these reactions combinedly gives redox reaction. So each of the above step is called half reaction, which explicitly show involvement of electron, and some of these reactions will give us overall reaction. So let's check the overall reaction once more. So these are the two half reactions, oxidation and reduction half reactions. Let's add these two reactions together. So all of the reactants of both the half reactions, let's mention we have 2Na plus Cl2 plus 2 electrons, and now all of the products on right hand side. It gives 2Na plus 2 electrons plus 2 Cl minus. Now just like in mathematics, common things on both ends will be cancelled out. So we have 2 electrons on both sides, so it will be cancelled out. So our net reaction is 2Na plus Cl2 produces 2Na plus 2 Cl minus. That means these two will combinedly give us 2NaCl. That means sodium chloride molecules. Now it may not be out of context to mention here that the new way of defining oxidation and reductions has been achieved only by establishing the correlation between the behavior of species as per classical idea and their interplay in electron transfer change. That means, as we already know, some of the elements will accept the electrons, some of the elements will lose the electrons. So this new definition is based on that context. That means at least one of the elements should accept the electron and it will be reduced, and one of the elements should release the electron, so it should be oxidized. So same is mentioned in reaction 8.12 to 8.14. So both of these all of these reactions shows reduction and oxidation, and we also discussed about agents, that means reducing agent and oxidizing agent. So elements which gets oxidized, they also reduce other element, and that's why it is called reducing agent. That means let's understand it with our given reactions. So as we know, our main reaction is sodium loses electron and chlorine gains electron. So that means because sodium releases electron, chlorine can accept it. And that's why because of sodium, chlorine is reduced. Okay, because of sodium, chlorine is reduced. That's why sodium is known as reducing agent. Okay, so reducing agent, that means sodium is being oxidized during the process. Similarly, because chlorine accepts electron, sodium can release it. That means sodium can oxidize because chlorine is able to accept. So for chlorine it is reduction reaction, but it gives oxidation reaction to sodium. That's why chlorine is called oxidizing agent. On the other hand, oxidizing agent itself will be reduced. So reducing agent will be oxidized and oxidizing agent will be reduced during the reaction, but these names are given based on their effect on another compounds. So that's why in this reaction sodium, which is oxidized, acts as a reducing agent because it donates electron to each of the element interacting with and thus helping reducing them. Similarly, chlorine, oxygen and sulfur are reduced and they can act as oxidizing agent because these accepts electron from the sodium, and that's why sodium is being oxidized. And in short, to summarize, oxidation, that means loss of electron by any species, reduction, that means gain of electron by any species, oxidizing agent, that means acceptor of electron, and reducing agent, that means donor of the electron. And now, based on this theory or electron transfer method, now we can justify the reaction Na plus H2 produces NaH. It is the redox reaction, and which of the element follows which path. That means if we see this reaction, then sodium is more electropositive than hydrogen, or hydrogen is electronegative than the sodium. So usually electropositive elements loses electron and electronegative elements gains electron. So in this case, sodium being less electronegative, it loses the electron. Hydrogen being more electronegative, it gains electron. So electron transfer takes place between sodium and hydrogen from the sodium to the hydrogen. That means we have these type of half reactions. In first reaction, sodium loses electron, so it is oxidation half reaction, and in second reaction, hydrogen gains electron, so it is reduction half reaction. And when we add these two reactions together, our final net reaction will be 2Na plus H2 produces 2NaH. That means 2Na plus 2H minus produces 2NaH. So in this reaction, sodium loses electron, that's why it follows oxidation reaction and it will act as reducing agent. Similarly, hydrogen gains electron, that's why it will be reduced and it will act as oxidizing agent. So same thing is explained here, but if you still find any difficulty, feel free to ask, and from the next lecture we will discuss our next topic. Thank you.